Today, let's strengthen one of our core mathematical understandings, and that's equation manipulation. Traditionally, when we have an equation, let's say x minus 1 is equal to 2, what we would do is we would quote unquote move this minus 1 across the equal sign. It would change sign, so we would have 2 plus 1 and we get 3. In like manner, if we had 3x minus 2 is equal to 3, let's do plus this time. We would move this 2 across the equal sign. It would change sign, so we would have 3 minus 2. Then we would move this 3 that is being multiplied across the equal sign. But in this case, it doesn't change sign, but it becomes a division. Now, it sometimes becomes a bit ambiguous as to how we move across something to the effect of a square, the square on the top here. So, to create a more systematic way to deal with equation manipulation, let's change our perspective. Let's have a change of view of the window through which we're going to see equations. So the way I want to think about an equation is like a seesaw, a balanced seesaw. Let's say we had a seesaw, and to keep it balanced, we put a weight on both sides. And let's say this weight was x and this weight was also x. Because it's the same value, it's going to be balanced. So if I added 5 pounds here, to keep my seesaw balanced, I would also need to add 5 pounds here. If I added a block here which was minus 2, I would also need to add a block here which is minus 2 to keep my equation balanced. If I added a block here which was divide by 3, I would also need a divide by 3 block here. So what I'm demonstrating is I could do anything I want to do to one side of my equation, my seesaw, as long as I do the same thing to the other side, and that would keep it balanced. So let's apply that idea now to an equation. Let's say we had x plus 2 is equal to 5. And what I want to do is solve for x, or to get x to be by itself as the subject of the formula. What is stopping x from being in that position is this plus 2 here. So to eliminate this plus 2, I would minus 2 from both sides of the equation. So I'm going to have x plus 2 so I'm going to have x, these would give 0, and 5 minus 2, well, that's 3. Now, if we look here, it seems as if this 2 has jumped across the equation and changed sign. But what really happened is that we minused 2 from both sides of the equation. Now, another example of this would be if we had something to the effect of this. Right, so we want to solve for x. We want to get x to be the subject of the formula. The first thing I would do is want to get rid of this plus 1, this minus 1, sorry. And how do I do that? Well, if I added a 1 here, if I added plus 1 here, these two are going to cancel. And I'm allowed to do that as long as I do the same thing to the other side of the equation. So let's get that. And again, it seems as if it would look like this minus 1 has jumped across the equal sign and changed sign. But in reality, what had happened was we added 1 to both sides of the equation. So we would have And now we're almost there. The only thing stopping x from being the subject of the formula by itself is this 3. So again, I want to get rid of this 3. So I would divide both sides by 3, because these will cancel to give me 1, and that's exactly what I want. So I see that x would be, and what's 3 over 3? That's 1. Right, so this is a different way to think about equations, and it clarifies the steps involved in solving any particular equation. Next, what we'll do is we will put these into 6 solid steps, so we have some tools to use for any equation situation.